Okay, verifying trigonometric identities. So the first question we have is to verify that cosecant squared theta minus 1 divided by cosecant squared theta is equal to cosine squared theta. So we're going to use Pythagorean identities. So the first thing I'm going to do is write these down. So the Pythagorean identities that we know. So sine squared theta plus cosine squared theta is equal to 1. Cosecant squared theta minus 1 is equal to cotangent squared theta. And secant squared theta minus 1 is equal to tan squared theta. So there we go. So when we're solving these problems, we want to look for the most complicated side, and we need to change that to equal the other side. So I'm going to use the left-hand side because it's the most complicated. And if we look at what we have here, cosecant squared theta minus 1, we can see cosecant squared theta is equal to cotangent squared theta. So I'm going to rewrite as cotangent squared theta. So I'm going to leave cosecant as it is for a second. Actually, let's change this to x as we're looking at x in the question. So the next thing I can say is cosecant. Well, I know that cosecant squared theta, this is equal to sine. So this is 1 over cosecant is equal to sine squared of x, as we're using x. So I'm going to rewrite this. So I've got cotangent, and we can say this is over 1 divided by, or multiplied by 1 over cosecant, which would be the same as sine squared. Now I can rewrite cotangent. Let's get rid of that bit with it. I can rewrite cotangent because we know cotangent x is going to be equal to cosine squared over sine squared. So this is going to be cosine squared over sine squared. And we're multiplying by sine squared of theta. So our sines will cancel and we're left with cosine squared, which if we look at our question, that is equal to our right hand side. Okay, so let's have a look at another question. So this time the right hand side is more complicated, so I'm going to take the right hand side and prove or verify that it's equal to the left hand side. So we need to still use the Pythagorean identities or the quotient identities. We're going to use everything that we know. So let's have a look at secant. So secant of theta, this is equal to 1 over cosine of theta. So I'm going to rewrite that as 1 over cosine of theta. We know that cosecant of theta is 1 over sine of theta. So let's rewrite that. We know that tangent of theta is equal to sine of theta over cosine of theta. So this is going to be sine theta over cosine of theta, and then we have minus 1. So if we look at our sines, these will divide, so there's going to be 1, so they are cancelled. So on the top, 1 times 1 is 1, so 1, and cosine multiplied by cosine, so that's cosine squared theta, minus 1. Now 1 over cosine squared theta, So 1 over cosine squared theta is equal to secant squared theta. So if we replace that, we'll have secant squared theta minus 1. Now our Pythagorean identities tells us that secant squared theta minus 1 is equal to tan squared theta. So I can rewrite this as tan squared theta. Now if I look at this here, this is my left hand side. So we can say that we verified. Okay, so let's have a look at this question. If we look at the left hand side is more complicated. So let's have a look at what we know. So secant squared theta, this is equal to 1 over cosine squared theta. Cotangent squared theta, this is cosine squared theta divided by sine squared theta. And so let's rewrite secant as 1 over cosine squared theta multiplied by cosine squared theta over sine squared theta, and this is minus 1. So our cosines will cancel, so we have 1 over sine squared theta minus 1. So 1 over sine squared theta, we know this is cosecant squared theta, so we can write this, and this is minus 1. And our Pythagorean tells us the cosecant minus 1 is equal to cotangent squared theta. So I can rewrite this as cotangent squared theta. And then if we look at our question, this is the right hand side. Oops, right hand side. So we have verified.